Alright, welcome back. We're going to go through Kinematics Part 3. So, in the first video I kind of introduced you to the cast and crew. Second video I showed you the equations. Now, I just want to show you one other thing. I was going to, on this video, show you guys how to solve a problem. But I think the best thing I can do actually right now is explain to you guys the unit analysis. Because the units work beautifully here. Now, I want to take this equation right here. It's on your your second quiz rather. Vf squared equals Vi squared plus 2a delta x. So we have Vf squared, Vi squared plus 2 times the acceleration and the displacement. So we know our velocity is equal to, so we know our unit for velocity equals meters per second. We know acceleration is meters per second squared, and we know delta x equals meters. So we then use the units here, and we treat them as though they're variables. Like we can do math with them. I promise you this will make sense, just watch. So we have meters per second, and I'll put a parenthesis around it, squared, equals meters per second squared plus 2 times meters per second squared multiplied by meters. Now, we can remove our integer here. We can remove this 2. This 2 does not, it's just, we can ignore it. It's just saying, you know, 2 of these, ignore it. What this is saying is you have meters squared over second squared, because you square obviously the entire value, equals meters squared over second squared plus 2 times meters squared over second squared. Now, obviously you can factor this out. You take the square root of it. You take the square root of any of this, and what you do to one side you do to the other. Take the square root here, take the square root here, and boom, what do we got? Oh, right, a velocity. Meters per second equals meters per second plus square root of 2 times meters per second. Now, obviously, you know, when we're doing this with numbers, you know, the 2 can kind of, you know, you just kind of put that in with the numbers. But the point is the units work out. You end up with meters per second. Because an acceleration times a displacement, meters per second squared times meters, results in meters squared over second squared. Which then you can, you know, when you take the square root of it at the end, like obviously with velocity final, if you're calculating for that, you take the square root of that in the end. And you can do this with all of these. As long as you have the units, you can do the operations that the units represent, or the operations that are, you know, inherent to the problem, and then you end up getting your answer. I hope that helped.